2NURFM, a broadcast service of the University of Newcastle.
And this is the time I love in the studio because the intellect, the brain space just expands in the studio when Professor John O'Connor walks in, because it's like the ace beating the three. Good morning. Welcome along.
God.
Look, we're talking about, there are so many ways you can generate electricity these days. Of course, we know we've got coal-fired power stations, solar, wind, all of the above. But carbon-14... this is very, very interesting because this could be a game changer for generating electricity.
Carbon-14 is interesting because it's all around us. I mean, it's part of our life, but it is radioactive. And most of the carbon that we experience is carbon-12. It's got 6 protons and 6 neutrons, really stable. But because of cosmic radiation, we get a build-up of carbon-14, which is radioactive. It has a half-life of about 5,700 years. And that's not the only way you can build this. Now, to give you an example, not the only way you can create this. And in fact, there was a bit of an anomaly a few decades back. And the best way I can explain to this to you is, let's imagine you turn up at my place with you've just been to a wine auction and you've got this wonderful...
Say a cheeky 84 Beaujolais.
Yeah.
Nice.
And you go, look, I've done really well on this. I got a really cut price. I can take it away and say, no, sorry, that's a 97. And,
get out of my house.
And the thing is, the other form of radiation from carbon-14 was built up during what's called the bomb pulse, which was in the 1950s when they had the atmospheric test, the Russians and the Americans, letting off bombs, and the French as well, in the atmosphere. And that raised the carbon-14 levels. Before that, it was pretty steady. And it's steady over millennia. And that's why we can go backwards and we can get bones from a site, a Neanderthal site, and we can get the amount of carbon-14 out of that and say that's exactly...
How close do you get it?
It depends on how far you go back, and it depends on the method you use to measure it. But you can get it to better than 10%. In fact, sometimes even significantly better than that. And they dated the Turin shrouds that way. And they showed that they weren't 2,000 years old, they were more like 1,000 years old. I mean, sometimes that's all you need.
Yeah, that's right. But then you've got to believe as well, which is another story for another day. Power generation with the carbon, what does it all mean? Because people get very scared, and understandably, whenever we talk about radioactive or nuclear, it just sends a shockwave of fear.
Well, this is a double win situation because there's a lot of radioactive carbon which was produced in nuclear reactors. It's used as what's called a moderator. And so the carbon-12 that you put in there becomes carbon-14, and you've got to stockpile it somewhere so that it's away from people and away from the environment. And so you've got to stock it up. But the scientists at the University of Bristol have come up with this bright idea of using the carbon-14 there to make diamonds. Now, these diamonds, actually making diamonds, artificial diamonds, is really dead easy these days. And so they make these diamonds, and the diamonds containing the carbon-14, what happens when the carbon-14 decays is it fires out a really high-energy electron. That then makes lots of low-energy electrons, which then get stored in a capacitor in the same way as you would, it gets stored similar to a battery.
Yeah.
Now, this can then get stored up over a long period of time. And the thing is, this battery would last, half its power would die off in 5,700 years.
Imagine that, going to the shop and buying your batteries and never ever having to worry about
Well, of course,
back.
It doesn't produce a lot of power, but it would be ideal if you're sending a space mission like Voyager 1 and Voyager 2 off. On that, they're putting plutonium in those things, which is pretty serious stuff. This carbon-14 you could put under these missions. I mean, there's a thing... a plan to actually send something like 1,000 miniature solar sail satellites off to the nearest star. Now, this would be perfect for that because they don't need a lot of power. They need it from time to time, but you could put these small batteries in there. They'll last 10,000 years. And they're going to be there before 10,000 years is up.
It really is science fiction because if you go back to Superman and you've got the charging crystals, if you go into any of the science fiction shows, the Star Trek, they talk about powering the ships with crystals which look a lot like diamonds. Is this where this comes from? Because it's very similar. There's a lot of parallels.
No, because most of this diamond is normal carbon. It's a very low concentration of carbon-14. In the case of Star Trek, it's diluted lithium. Well, that's just lithium and lithium. I'm not quite sure how that one works, but anyway.
Don't go debunking Star Trek and Star Wars, otherwise you're in for big trouble.
I'm a Trekkie, don't worry. But and there's a lot of science in Star Trek, real science, but they've got to make up something for because we haven't invented. Because we haven't invented yet, so they've got to come up with an explanation why they can travel faster than the speed of light. But yes, this could last a long period of time, and power things that don't need a lot of power, but you want them on forever.
So basically something that needs to be technically in a sleep mode, but it needs just to be humming along a little bit like the standby on your Foxtel box or your television. And
your AA battery won't do that. I mean, after a few years, it's dead whether you've used it or not.
Yep.
So this thing will last longer than that.
I've learned a couple of things this morning. Thank you. Don't bring a cheap bottle of wine to your place. And 2, don't watch Star Trek. Professor John O'Connor, thanks for your time.
Thanks, Todd.
2 RFM 103.7.